Okay, now that we've been working with subtracting with mixed numbers, there's one more thing I need to show you that can be an area of complication. Let's take a look at our example. We have 2 and 1/3, and we're subtracting 1 and 2/3 from that. As usual, I'm going to stack my mixed numbers so that they're all lined up. Now when I stack my mixed numbers, I have 2 and 1/3 minus 1 and 2/3. Now there's something that stands out to me that should stand out to you as well. When I try to start my problem, my denominators are the same, but I can't take 2/3 away from 1/3. Alright, this fraction is smaller than this fraction. So there's something we need to do in order to help us out with this problem. I want you to think of a regular subtraction problem. Let's say we had 72 minus 48. Okay, as you look at this, you should notice that you can't take away 8 from 2. So what would we normally do? We would borrow from the 7. Now, that's basically what we're going to be doing with these mixed numbers. Alright, I don't have enough of my fraction here to take this away, so I'm going to borrow from my whole number. So basically I'm borrowing 1 whole from this 2. Now, we're going to rename this 1 whole as a fraction. Okay, so a couple of ways to rename 1 whole as a fraction would be 2/2, 3/3, 5/5. Okay, all of those are equal to 1 in fraction form. So I'm going to pick a fraction that is equal to 1 that is compatible with 3, which means it works with it easily. Alright, so we probably want 3 as our denominator. So I'm going to choose 3/3. So I changed my 1 whole to 3/3. Now I'm going to add that 3/3 to what we already have. What do we already have in this mixed number? We already have 1/3. So I am going to add 1/3, what we already have, and then I'm going to add this 3/3, or that 1 whole we borrowed from over here. When I add those together, I get 4/3. So basically what I've done is I've converted 2 and 1/3 into the mixed number 1 and 4/3. And what that allows me to do is it makes my fraction on this side large enough so that I could subtract 2/3 from it. Now I can subtract as normal. 4/3 minus 2/3 is 2/3. 1 minus 1 is 0. 2/3 is in simplest form, so that is my answer. Now, there's one more thing I want to show you as far as renaming. Let's say we have the whole number 7, and we're subtracting a mixed number from that. Let's say 2 and 2/3. Now, if I was to stack these as I should have 7 minus 2 and 2/3. What you should be noticing at this point is that I don't have a fraction part for my whole number, okay, for this 7. So what I need to do is I need to create a fraction part which will allow me to subtract 2/3 from it. Basically we have no fraction, so we need to create a fraction. So what I'm going to do is borrow from my 7. Once again I'm going to borrow 1 whole. So that's going to leave me with 6. So I borrow 1 whole, and I want to think of a whole that is equal to 1 whole that is compatible with 2/3, that works well with it. The one I can think of that would probably work best is 3/3, because the denominators are the same, and when denominators are the same, we know that things are a little bit easier. So I'm going to change this 7 to 6 and 3/3. Okay, 3/3 gives me 1. I add 1 plus 6, and I get 7. So basically, it has a value of 7, It's just written in a different way. And then I'm going to subtract 2 and 2/3 from that. And now my fraction for my top number is large enough so that I can subtract. So once again, I think of it as two separate problems. I have 3/3 minus 2/3, which gives me 1/3. I have 6 minus 2, which is 4. The fraction part of my mixed number is in simplest form, so this is my answer in simplest form.